Hello everyone, I'm Jingkai Li. Today I'm going to talk about how much has sea level varies over the last 100,000 years. Sea level changes have occurred throughout Earth's history. The magnitude and timing of sea level changes are extremely variable. They provide considerable insight into tectonic and climate history of the Earth, but remain difficult to determine with accuracy. All through geological time, sea level have fluctuated by more than 300 meters, but within recent 100,000 years, the sea level was always below the current level and varies within a range of 130 meters. Main reason for sea level fluctuation is the melting and the accumulation of Arctic ice sheet and other glaciers during the warm period and glaciation. And there are some other minor factors that we will discuss later. The study of sea level changes is important because it's not only related to people's daily life, but also influences the ecosystem in both coastal and marine environments. Let's first talk about the reasons for sea level changes. Global sea level has fluctuated significantly over the Earth's history. The main factors affecting sea levels are the amount and volume of available water and the shapes and volumes of the ocean basins. The primary influence on water volumes are the temperature of seawater, which affect the density and the amount of water retained in other reservoirs, like rivers, lakes, glaciers, and sea ice. Over geological timescale, changes in the shapes of water basins and in land-sea distribution affect sea level. In addition to global changes, local changes in sea levels are caused by tectonic uplift and subsidence. We see that change in the mass of ocean water play a major part, which include melting or accumulation of continental ice, climate changes since the 20th century, and long-term adjustment to the end of the last ice age. We can see from this picture that between the glacial and the interglacial, the total volume of sea water change along with the sea level. And the change in the volume of ocean basins also play a basis part. The plate tectonic and the seafloor expanding, the marine sedimentation, though these effects are small, but they are global. And this picture just show what we have said before. And the uplift and subsidence of Earth's surface and the sediment compaction that also have a very huge impacts on the local scale. When it comes to measurement, the record of sea level changes can be estimated by observing the stable isotope oxygen-18. When marine organisms build their tests from the calcium, carbon, and oxygen presented in sea water, they incorporate both the abundant oxygen-16 and the rare oxygen-18. Water in atmosphere generally has a lower oxygen-18 to oxygen-16 ratio because evaporation of lighter isotope requires less energy and is much favorable. As a result, the snow eventually forms the glaciers and ice sheet is duplicated in oxygen-18, leaving the ocean oxygen-18 enriched. Carbon-14 is also used to trace the sea level changes. However, it focuses more on the fossil, so it sometimes makes mistakes and not such reliable. In addition, the deepwater drilling methodology is sometimes applied in order to investigate detailed sea level data at a certain period of time. Let's see how the sea level changes over the 100,000 years. Take a look at the curve on the graph obtained by analyzing oxygen isotopes in the ice. It represents the fluctuation in the sea level from 200 years ago to the present. Approximately 100 to 25,000 years ago, the sea level was approximately 8 meters higher than it is today. It was during the Sangamonian interglacial, the last time the North Pole's ice cap completed melt. After this peak in the sea level, ice returned to the planet. 3 major glaciation and 2 interglacial periods ensued. This range is also known as Stage 5 for repeated glaciation. At around 70,000 years ago, the sea level finally dropped below 100 meters compared with current level, and the extremely low temperature indicate a huge glaciation occur, and this is the beginning of Wisconsin Glacier period. There are a few factorization. The Wisconsin glaciation followed between 80,000 years ago to 20,000 years ago, when it reached a maximum to about 130 meters lower than today, the sea level, and it is what people refer as Ice Age. And we can also see from this carbon dioxide concentration graph, and compare them, we can see that the concentration of CO2 is matched well with the sea levels and temperatures. During the deglaciation between about 90 to 8,000 years ago, sea level rose at extremely high rate as a result of rapidly melting of a Brenton Area Sea and the Inuit ice sheet, Laurentide ice sheet, and parts of Antarctica ice sheet. During the rise of earlier Holocene, the rate of sea level rise varies at a low about 6 to 99 mm per year to a high of 60 mm per year during the brief periods of accelerated sea level rise. And due to solid evidence, there are three major periods of accelerated sea level rise, which we call the melting water plus 1A, 1B, and 1C. And such rapid rates of sea level rising during the meltwater event clearly implicate that a major ice loss event related to the ice sheet collapse. You can see from this picture that the primary source may have been determined as the melting water from Antarctica ice sheet and the Laurentide ice sheet. In modern days, we can see that the sea level change rate in 18th and 19th century are relatively stable. However, in 20th century, sea level trend are substantially higher than those of the last few thousand years. The current phase of accelerated sea level rise appeared to begin in the late 19th century to the early 20th century, based on the coastal sentiment from member of stations. 20th century, the global sea level, as determined by the tide gauge in coastal harbor, has determined that a 1.7 to 1.8 millimeter per year is increasing, apparently related to current climate warming. Most of this rise came from warming of the world ocean and melting of mountain glaciers, which have receded dramatically in many places, especially during the last few decades. Since 1993, there are even higher sea level trend, about 2.8 millimeter per year has been observed by satellite altimeter. And analysis of high tide gauge record also suggests that a possible late 20th century acceleration in global sea level. Recently, observations of Greenland and the western Antarctic ice sheet raises concern for the future. It has been seen that it's adding 0.23 to 0.5 millimeters to the sea level per year in the last decade. And it has been estimated that if all the ice melts on the Earth, there will be 5 to 7 meters sea level change. And even 2 to 5 degrees change will completely destroy the stability of Greenland. However, any significant meltdown would take many centuries. And furthermore, the scale of the meltdown currently cannot be matched with any meltdown plus in the history. To sum up, sea level changes are either a response to the changing ocean volume or the changing in the volume of water contained in the ocean. The timing of sea level changes is observed from 100,000 years ago till now. Magnitude varies significantly, but within 130 meters. At about 100,000 years ago, the sea level was about 50 meters below current sea level. And after that, several repeated glaciation occur, and resulting the sea level just going up and down. After that, at about 70 years ago, the Wisconsin glaciers happened, and the sea levels just dropped to a lower point, and after a lot of fluctuation, finally, at about 90,000 years ago, the sea level dropped to its minimum point at about 130 meters below sea level. And after that, the sea levels recovered by the meltwater plus. In the modern days, the global warming is a cause of the acceleration of the sea level rising. There are still some challenging in the research, which include the estimate of sea level changes currently suffer from significant range of uncertainty, both in magnitude and in timing. However, scientists are working hard to estimate the sea levels changes by using different data and analytical approach. That's it. Thank you for watching.